Hello everyone. When we last left off, we did some basic parsing. So today I will go over parsing in more detail this time. So parsing, given a sequence of tokens, we determine what that sequence of tokens is, and then we determine whether what that sequence of tokens should translate to. And then if there's an error, like let's say you're missing a semicolon or you're missing a func keyword at the beginning of a function, then you spit out an error if an invalid sequence of tokens occurs. So when it comes to parsing some very simple statements, we can do something like what we describe in this pseudocode over here. Let's say that we have a statement like int variable semicolon. To parse that, we can get the first token. If the first token is not an int keyword, we return false. We get the next token. If the token is not an identifier, then we return false. If the next token is a semicolon, then we return false. If all of this stuff, if it's a int keyword followed by an identifier followed by a semicolon, then we can return true because this is a valid statement. Parsing statements, it can get a little bit more complex. So you can have things like token equals next token if the first token is an int keyword followed by an identifier and then followed by an equal sign. Then to parse something that is a little bit more complicated, like let's say then you can call a function like parse expression and then use the parse expression to parse the expression. This expression could be something as simple as maybe like 0, or it could be 1 plus 1, or 1 plus 2, or 1 plus 3 times 3, or 3 divided by 2 times 2 minus 1 times 4. The expression can be either very simple or it could be very complicated. And what we'll do is that we'll call a function to parse call a function and use the function to recursively parse a complex expression, and then followed by the next token, and if the next token is not a semicolon, then return false, else return true. So if you have something like a while loop, you get the while keyword, then you parse the Boolean expression, then you parse the left curly brace, then enter a loop, and then you parse statements. If the statement is epsilon, then break out of the loop. If there's no more statements, then break out of the loop. You parse the statements using a function, and then you call that function recursively. Then you parse the left or the right curly brace, and then return true if everything parses correctly. So for parse expression, so in parse expression, an expression is a multiplicative expression. It's a multiplicative expression and followed by any amount of add and subtract. So you have the left-hand side of the expression, then you follow that with the right-hand side, and then a plus in between. So what you'll do is you'll get the multiplicative, you parse the multiplicative expression, the left-hand side first, then you recursively parse the right-hand side of the plus and minus sign. And then in multiplicative expression, what you can do is that you can have you can recursively parse the left-hand side of the multiplicative expression, then follow that by the times, divide, and modulus, and then parse the other half. So you use recursion to parse the left-hand side of the multiplicative expression, then you use the right-hand side to parse the right-hand side of the multiplicative expression. The reason we divide up the expression into expression and multiplicative expression is because we want the multiply divide, and modulus to take higher precedence than add and subtract. And to do this, what we do is that we have the add and subtract as higher in the parse tree, and then we make the multiplicative expression lower on the parse tree so that the multiplicative expression gets done first in the recursive step, and then the add gets done later so that we can have the correct precedence for the multiplicative expression. This is important for code generation where we want expressions to have the correct precedence, order of precedence. And then parse term, if it's a number, then we return true. If it's a variable, we return true. If it's an identifier, then etc. And then the rest of this stuff is, since the rest of the slides are syntax diagrams. So the terminals, these are just terminal tokens, and then non-terminals you can use recursion in order to figure out what the non-terminals are. So for every terminal that you encounter, just parse the you can parse the token. For every non-terminal, use recursion to try and use a function and call it recursively in order to figure out what the non-terminals are supposed to be. So for example, in program semantics, we have functions, so we call functions in a loop, and then we parse all the functions. So for this project, take these syntax diagrams and then translate them into code, and that should generate the correct parse tree. That should correctly parse a program. So I guess this is the function semantics. You have func keyword and an identifier, a left parentheses. You go in a loop and then you parse all the declarations. You have a right parentheses, a left curly brace. You parse all the statements in a loop. You call a function that parses all the statements, then end up with a right curly brace. A declaration, it's simply an int keyword, an identifier, or maybe an alternative path is that if you see a left curly brace and then a number and a right curly brace, then you also do that. Yeah, here's statements. All these statements, they have different sort of branching. Like for example, break is a different pathway than continue, because break, I guess it's one keyword and then followed by a semicolon. Continue is the continue keyword followed by a semicolon. And then things like declarations, I guess they start with int and then they have an a afterward. They have an a afterward followed by a semicolon. Then the branches have different kinds of. They start with different keywords next. So that's how you can distinguish between the different kinds of statements that you could have. You can look at the way that the first token is done. You could look at the first token and then you could branch appropriately based off of how it is done. Yeah, this is you can go over all of these syntax diagrams on your own. So